viewers, Assalamu alaikum. We are going to differentiate conductor, insulator and semiconductor. First we are going to describe conductor, that what is conductor, actually how we can define the definition or how we can define the word conductor. The material that easily conduct what? It easily conduct electrical current. That material in which electricity can flow, we call it conductor. In which electricity can flow. Mostly metals are good conductors. That there's a lot of metals that they are conductor. The best conductor are single element material. It means that the best conductor are those that they are made up of single element. I.e. that has copper, silver, gold, etc., which have only one electron in its valence shell, and there is shell around the atoms, and there is only one electron in their valence shell. We call the conductor because it is loosely connected to that atom, and there is a very small force on that electron, and if we apply a little bit force on it, and it will eject the electron. Now we are going to describe the word what? Insulator. The material that does not conduct electrical current, and which electrical current cannot flow. In which there is no free electron. In conductor there is a lot of free electrons through which it can flow. The electrons can flow, but in insulator there is no free electrons to conduct electricity. Due to this, electrons can't flow. And insulator, most good insulators are compound rather than single element materials. It means that insulator is made up of different element. A conductor is made up of single. The best conductor or those good conductors are those that they are made up of single element. But insulator, on the other hand, insulator is made up of different elements, compound, and it have high resistivity. And insulator there is a high resistivity. Valence electrons are tightly bound to the atoms. I told you earlier that in conductor the electrons are loosely connected in their shells, while in insulator the electrons are tightly bound to the atoms. It has no energy that they eject the electrons. If we pass some high energetic, it does not eject electron insulator. And just like example, that is rubber, plastic, mica paper, and glass, etc. These are the example of insulator. Now we are going to describe the word semiconductor. That what is semiconductor? Semiconductor is that type of material that is not a proper conductor, not a what? Insulator. Semiconductor. The material and between of what? Conductor and insulator, we call it semiconductor, which is not properly a conductor nor properly insulator. At hand, not too much free electron as a conductor, and it is not too much unfree electron just like insulator. There is no free electron in insulator, but in semiconductor there is, and somehow it has some free electrons compared to insulator, and they have some free electrons, but in conductor the quantity of free electrons is greater than as compared to this semiconductor. So this is the definition. The material and between of conductor and insulator, we call it We call it semiconductor. But in semiconductor, sometimes it's made of single element and sometimes it's made of compound element. So we are going to discuss a single element. Single element, we get some example of element that they are. I mentioned some some materials that they are made of single element, just like and these elements, just like I mentioned first, I mentioned boron, I think so, arsenic, polonium, also polonium, etc. These are the examples of single elements, and these all are semiconductor, and they are made of single elements, Behind this, we are going to introduce the compound element, which is made of different elements, just like gallium arsenide. Gallium arsenide is the example, and I think so. Gallium nitride, yes, gallium nitrate as also is the example of what? These both are semiconductor, but this semiconductor is made up of single element, and this semiconductor is made of compound element, and they both have free electrons, and they obey some rules of insulator as well. Due to this, we call that type of material that is in between of conductor and insulator. They both have free electrons. In that, and these semiconductors, there is some amount of free electrons, which is the quality of conductors. And behind this, if you're looking for insulators, and there is and they are some electrons are not free, that they can move from one place to another, which is the property of insulator. And also the property of conductor as that they are made of single element, and the property of insulator that they are made of compound element. And these both qualities are matched with each other, so we call that type of material that is in between of conductor and semiconductor. Now we are going to elaborate the diagrammatically that how they differentiate with different from each other diagrammatically. That what is the difference between what conductor, semiconductor, and what I think so insulator. Yes, insulator. What is the difference between these things? So I'm going to discuss one by one. So I'm going to discuss how how's the energy it shows. This line shows energy. This line shows energy. Here, this is the band. That's we call it valence band. And this is called conduction band. This is the valence band, and this is the conduction bands. As electrons move from, let's suppose, first I'm going to elaborate insulator. That what is insulator? It is for insulator. It is for what? It is for insulator. And this place from here to here, we call it bandgap. Okay, this is bandgap. What is bandgap? The energy difference between the valence band and conduction band. Or we can also define it in other words, just like first of all, we are going to define just like that the energy difference between the valence band and conduction band, or we can also define as the minimum energy required for the electrons through which it can move from valence band to conduction band. This is the insulator. So this distance is too far. Even each and every electrons no one electrons in valence band have much energy that can move from here to conduction band. So this is due to this, electrons can't move from here to there. This is the property of insulators, and there is no free electrons to move there. So behind this we are going to elaborate what? We are going to elaborate semiconductor. Yes, semiconductor. Okay, this is energy, and this is the conduction band, and this is the valence band, and there is a lot of free electrons in the valence band. Here there is a lot of valence, there is a lot of free electrons. Electron move from here to here to the conduction band. Electron move here. So so this distance from here to here we call it band gap. How we can define the band gap? The energy difference between valence band and conduction bands. The energy difference between valence band and conduction band, or in the other words, we can define this band gap, the minimum energy required for an electron through which it can move from valence band to the conduction band. So this distance is too far, and the electrons have not too much energy that can move from here to there to conduction band. But here there is some electrons. But in semiconductor, it is the group of what? Semiconductor. But in semiconductor, there is some electrons that they have much energy they have the ability, and they have much energy that can move from valence band to the conduction band. Let's suppose I'm going to discuss it. Let's suppose electron, here is electron. Here is the electron, electron. It is moved from here to which is moved from valence band to the conduction band, electron. So electron move from here. So here it is the empty hole. It creates hole. It creates what? Hole. It creates hole, and here and the electron there is negative charge. In electron there is negative charge, and here if electron left this place and move to the conduction band, here it creates what? Holes, which is positive charge. Which is positive charge, and here is negative charge, and here is positive charge. So this is the main concept. Now I am going to discuss about conductor. Okay. Conductor. I'm going to talk about conductor. Okay, conductor is so easy one. Here is the valence band, and here is the conduction band. It is too near to each other. Conduction band. It is too near to each other. Due to this, this is the overlapping place. We call it overlapping. It's not a band gap. It's just a small little place. It is very little place, little side through which, and there's a lot of electrons, and I told you that there's a lot of free electrons in the valence band. Even they have the ability, and conductor. This is for conductor. This is what? Conductor. And they have the ability that they can move from valence band to the conduction band very fastly. There are a lot of free electrons, and they are too near to each other, and they can move easily. Compared to this, it is slightly difficult, but compared to these both, it's not possible. It's not possible for electrons that can move from valence band to the conduction band. If we come to this one, this electrons can move from here to, it creates hole, and here it is the negative charge on electron moves from here to the conduction band, and here the hole is created, which is positive charge. And also if we elaborate too much more, and the semiconductor is also have type, just like intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are those semiconductors which are pure. Extrinsic semiconductors, if we dope something, if we dope impurities if you drop impurities in the intrinsic semiconductor, so it becomes extrinsic semiconductor. And extrinsic semiconductor have also two types, just like p-type and n-type semiconductor. In the p-type of semiconductor, there is majority of holes, positive charges, while in the other hand there is n-type of semiconductor, and which and p-type of material, there is a majority of what, holes, and minorities of electrons or negative charges, while in the other hand, if we're talking about the n-type of semiconductor, and n-type of semiconductor, there is a majority of negative charges, and there is minorities of what, positive charges. This is the topic all about the semiconductor, what is the difference between conductor and semiconductor, and insulator, and I discussed the graphically definitions, all the things. Also I described the semiconductor types, intrinsic and extrinsic, but not too much. But as the types is also type of p-type, and n-type is the intrinsic, and extrinsic is the types of semiconductor, while extrinsic semiconductor is also divided into two, which is p-type and n-type. So thank you so much for watching my videos. If you like my videos, you should subscribe and click on the bell icon. Thank you so much.